Most of us jump in a car pretty much every single day. But have you ever really stopped to think about what's happening under the hood? It's this incredibly complex machine we totally take for granted. Well, in the next few minutes, we're going to change that. We are going to demystify the amazing journey of power that kicks off the very second you touch the gas pedal. It feels so simple, right? Your foot goes down and the car just goes. But in between those two moments, there's this amazing symphony of engineering, all these different parts working together perfectly. So in this explainer, we're going to follow that single command from your foot all the way to the tires gripping the pavement. So here's our game plan. We'll start with the absolute basics. What actually holds a car together? Then we'll dive right into the engine, the true heart of the machine. After that, we'll see how all that power gets to the road. And finally, we'll look at how you control it all. It's the whole journey of energy, from the spark of creation to making the car move. All right, let's kick things off at the absolute basics. Before we can even start talking about making power, we've got to understand the foundation that everything else is built on. Okay, so think of the chassis as the car's skeleton. Seriously, it's the core framework that has to support everything. The engine, you, your passengers, and it has to handle all the bumps and forces from the road. And it's more than just a simple frame. It includes the suspension, the axles, the wheels, basically everything connecting the car to the ground. So if the chassis is the skeleton, then the body, well, that's the skin. This is the part we all see and touch. The doors, the roof, the hood. It's what gets attached to that skeleton to create the space for us and our stuff. And of course, it gives the car its unique look. Now, there are really two main ways to put a car together. Body-on-frame is the old-school, super tough method you'll see on big trucks. But almost every modern car you see uses a unibody design. Why? Because by welding the frame and the body into one single piece, the whole car becomes way lighter and much, much stronger. And that's a huge deal. It improves everything from how safe you are in a crash to the gas mileage you get. All right, with the structure covered, let's get to the main event, the engine. This is the power plant, the beating heart of the whole vehicle. Its entire job is to take the chemical energy locked inside gasoline and turn it into the raw, mechanical motion that gets you wherever you need to go. So where does this motion even begin? It all starts right here, with this little guy, the piston. Inside the engine's cylinder, a tiny, perfectly controlled explosion of air and fuel happens, and that blast forces this piston down. Its job is to capture all that explosive force and turn it into a simple, powerful, up and down motion. But that's just the very first step. That raw up and down force from the piston has to go somewhere, and that is the simple but absolutely critical job of the connecting rod. It's basically a super strong bridge that transfers that energy to the next key component in the chain. And this is where the magic happens. The connecting rod pushes and pulls on the crankshaft, which is really the backbone of the whole engine. And as it does that, the crankshaft brilliantly converts that straight up and down movement into the spinning rotary motion we need to actually turn the wheels. Every single rotation of your car's tires begins right here. So let's not underestimate this little guy. The piston is a real workhorse. It doesn't just move. It has to create a perfect seal to trap that explosion, it has to transmit a massive amount of force, and it has to act as a super durable pivot point for everything. It's a small part, doing a huge, huge job. So we've created rotary motion. Awesome. But there's a problem. That raw power coming off the crankshaft is, well, it's kind of wild. It's spinning way too fast to be useful. So this next section is all about the transmission system, the parts that tame that power and deliver it to the pavement in a way we can actually use. Let's follow the power on its journey. It starts with the clutch, which connects the engine's spin to the gearbox. The gearbox is amazing. It uses different sized gears to control speed and torque. And torque is just that raw, twisting force that gets you moving, from a dead stop. Lower gears give you more of that grunt for acceleration, while higher gears let you cruise at high speed. From the gearbox, a propeller shaft spins and sends that power to the differential. And the differential does one last super clever job. It lets the left and right wheels spin at different speeds, which is absolutely critical for making a smooth turn. Okay, power is hitting the pavement. We're moving. Now, how do we actually control this thing? This last section is about the commands we give the car, but also about the invisible forces it's constantly fighting. While we're steering and braking, the car is in a non-stop battle with the world around it. And the biggest opponent? Air resistance. We're all focused on the controls we can touch, right? The steering wheel, the brake pedal, but your car is in this constant, invisible fight with the air itself. We call it aerodynamic drag, and it's a resistance force the engine has to overcome every second you're moving. It plays a massive role in how efficient your car is. And this table really shows you what that battle looks like in numbers. This drag coefficient, or CD, is just a simple number for how easily something cuts through the air. And wow, look at the difference. A sleek racing car just slices through with a tiny number. A big, boxy truck, on the other hand, has to shove a massive wall of air out of the way, so its number is huge. It really proves that when it comes to efficiency, shape is everything. So here's the science. Now, don't let the formula scare you, but it tells us exactly what's going on. You can see our friend seed, the drag coefficient, right in there. But the most important part, the bit that has the biggest impact on your drive, is that very last term, v squared. So what on earth does v squared actually mean? Well, the v is for velocity, your speed, and because it's squared, the force of the air pushing back on you increases exponentially the faster you go. Doubling your speed, say from 30 to 60 miles per hour, doesn't just double the resistance, it quadruples it. That's not double the work for your engine, it's 4 times the work. And that is exactly why your fuel economy takes a nosedive at high highway speeds. So there you have it. We've traced the entire journey, from a simple push of your foot, through the fiery heart of the engine, down the drivetrain, and finally to the road. For over 100 years, this internal combustion engine has been this incredible marvel of engineering that literally shaped our world. But as we look to the future, this elegant system of pistons and crankshafts is facing some serious competition. So the question on the screen is the one that will define the next chapter of the automobile. What will power it next?